In Unit 1718, we are going to be looking at rates of change. So you may remember rates of change. We started looking at it in grade 9. We called it slope, but rate of change is how the dependent variable of a function, so the dependent variable being y, changes over an interval of the independent. So the dependent being y and the independent being x. So if we remember, the rate of change is delta y over delta x, or the difference in the y values divided by the difference in the x values. So we designate y2 and y1, x2 and x1 as being 0.1 and 0.2. And the reason we designate it as 0.1 and 0.2 is because we want to subtract the y values and the x values in the same direction. So we just say this is going to be 0.2, this is going to be 0.1, and then we are always subtracting in the same direction. We can represent functions with tables of values, graphs, and equations. So we're going to look at rates of change in those three different ways. If we had a table of values, perhaps we want to find the curve's position that changes over a time interval. So we'll just pick a time interval. I'm going to pick between 0.1 hours and 0.5 hours. So if I'm doing delta y over delta x, I have a table of values. So I'm trying to find the average rate of change between these 2 points in the table. So we are looking for delta y over delta x, or y2 minus y1 over x2 minus x1. Doesn't really matter which point is 0.1 and which is 0.2. I'll call this one 0.1 and I'll call this one 0.2. So if I'm doing delta y over delta x, it will be 60 minus 12 over 0.5 minus 0.1, which is 48 over 0.4, and if we do that division we get 120. Don't forget to put units if they are included. I see that this table is measuring in kilometers per hour, so just make sure that we include the units. So the rate of change between 0.1 hours and 0.5 hours is 120 kilometers per hour. Also plot those points on a graph and we can find it in the same way. So I'm going to find it between this point and this point. So we would have delta y and we would have delta x. This is my delta y, this is my delta x. Not as accurate with a graph. I can see that delta x is between 0.1 and 0.5, so that's pretty easy to calculate. Or I can count squares. When I go to look at delta y, I'm not quite sure that this first point is exactly on 10. It might be a little bit higher. So my delta y might be more of an estimate with a graph. So it's much more accurate if you have exact points or if you have an equation. And in this example, we have an equation. So we are given the height of a pebble falling off a cliff. So I've got this cliff, I've got this pebble falling to the ground, and I'm looking to find the average rate of change between 1 second and 4 seconds. So perhaps it's here at 1 second. Oops, that's y. And then I want to know what it would be between 4 seconds. So let me change this. So this is 0.1, and then the y value would be the function at 0.1. This is 0.2, and this would be the function of the value at 0.2. And so if I'm doing the average rate of change, I'm looking for delta y over delta x, or y2 minus y1 over x2 minus x1. If I have the equation, I might say it's the height at 4 seconds minus the height at 1 second over 4 minus 1 second. So height is representing the y value and time is representing the x value. So then we would just put the values into the equation. So just make sure you keep these separated by brackets before we do our simplifying. So h of 4, I just substitute 4 into the equation, and then I'm going to subtract h of 1 using the same equation. And then that will be over 4 minus 1, which is 3. And then we would just do those calculations on our calculator. Just type it in. You don't have to do all the steps. So h at 4 works out to be 130. H at 1 works out to be 170 divided by 3, and then that works out to be minus 13.3. The height is measured in meters and the time is measured in seconds. So a negative height, if we look at what we're measuring from 1 second to 4 seconds, I can see that the average rate of change is decreasing, it's going down, so I would expect the answer to be negative. And you can see it visually on this graph. Here's the height at 1 second. Here's the height at 4 seconds, and I'm looking for the rate of change between those 2 points. So this point worked out to be 1 and 130 meters, and this point worked out to be 4, and it was 170. The line that connects 2 points is also called a secant line. So we refer to this as a secant line. So when I'm finding the average rate of change, I'm also finding the slope of the secant line. Okay, in this example we have a hot tub that is full of water. It holds 1,600 liters when it's full, and it takes 2 hours to drain it, and we want to determine the change in volume between 60 minutes and 120 minutes, or the second hour. So the volume is given as an equation, and we want to find the average rate of change between 60 minutes and 120. So again, we'll do delta y over delta x, or in this case it will be the volume at 120 minus the volume at 60 over 120 minutes minus 60 minutes. So we'll just put those values into the equation. Generally, if there's any errors made, it's usually a calculation error. It's not too difficult to find the rate of change or the slope of the line, but sometimes we make mistakes when we are plugging in these numbers into our calculator or into the equation. So just be careful when you are doing these calculations. So the first one is obviously 0, because 120 minus 120 is 0. And the second one works out to be 400, and that's over 60. So once we do that division, we get minus 6.67, and this is liters per minute. So the volume of the hot tub is draining at an average of 6.67 liters per minute. Okay, so as mentioned before, the average rate of change between 2 points is also called the slope of the secant line. So any line that passes through 2 points is called the secant line, and the average rate of change represents the slope of that secant line. And we can use the formula in general, y2 minus y1 over x2 minus 1, or delta y over delta x.